Okay. So we're going to talk about this concept called the mole. And when we're, just like I said before, this is going to be math-based only. Okay. So we're only calculating for this entire unit. And the next test is going to be just calculation. So yes, obviously you need your calculators the whole time that we're doing notes, because we're going to be solving the problem on the board, and then I'll give you a bunch to solve. Your tests have been graded. They're posted, except I have a few makeups, so I have to wait until everybody's done taking their makeups, and then I will give them back to you. Okay? All right. So on that note, and we are going to do lab, but I think we're going to do lab with moles. It's a little bit more fun than. So we're going to do the mole lab. So when we're talking about moles, we can always refer it to something called Avogadro's number. Avogadro's number is a constant number. What it states is that any one mole, and one mole is a quantity, right? It's a given quantity, which we'll look at. Any one mole contains this many atoms. Okay. Now, the term can be either atoms, molecules, or formula units. They all mean the same thing. Atoms have to do with an element. So if I say 1 mole of oxygen, how many atoms are in 1 mole of oxygen? What would you say? 0.022 times 10 to the 23. If I say 1 mole of sugar, how many molecules?
6.02 times 10 to the 23.
If I say 1 mole of sodium chloride, how many formula units?
6.02 times 10 to the 23.
Okay, so if we're talking about an ionic compound, we call it formula units. When we're talking about a covalent compound, we call it molecules. When we're talking about a pure element, we call it atoms. It's the same thing. 1 mole of anything at all has this many atoms, molecules, whatever it is, right? But this is Avogadro's number. It's a constant. We're always going to use this. And since it's a constant, it'll be given to you on the test. Okay? All right. Now, let's define this mole. Atoms are so tiny that 1 mole of atoms is about a handful. Well, it can be, or it can be a little bit more than that, right? The mass is that average atomic mass. Remember, we spent all that time calculating the average atomic mass? Okay, so now we're going to use that average atomic mass to calculate grams and moles and molecules and all that good stuff. Okay, 1 mole of carbon is 12.01 grams. How do I know that? When you go to the periodic table, you look up carbon, you're going to see that the average atomic mass of carbon is 12.01, which means that 1 mole has 12 grams. Okay? 1 mole of sodium, 22.99. How do I know that? That's the average atomic mass. Okay? So what would 1 mole of hydrogen be? Well, it's 1.00, so 8 grams. So you just basically look at the periodic table to determine the mass. Okay? So, what is the mass of 1 mole of neon atoms? How do I do that? Okay, so you go to the periodic table, you find neon, which is right here, and on, what does it say? 20.18. So what that means is that 1 mole of neon is 20.18 grams. Now, why are we even bothering with grams? Because it's what we can measure. When we're using a balance, right, and I want to, let's say, react 5 grams of sodium with water, I can measure grams, right? It's easy to do. You just take out your balance, you put it on there, it'll tell you grams, you know what you're dealing with. Then I can use that to convert to moles, convert to atoms, depending on my problem, okay? All right, so that's what 1 mole of sugar looks like. That's 1 mole of lead, copper. What's going to differ between the 1 mole is the mass, right? But is the number of atoms going to differ? No. It's just that per atom, this is a lot more massive, right? It's lead. I think it's like 200 something. Versus water, which is 18 grams per mole. Sulfur is 32 grams per mole, and so on. Okay? Now, when we're doing calculations from atoms to molecules, that's molecules, but I write out molecules. You want to write it out that way, that's fine. Not so crazy about that abbreviation. I just write out molecules. Okay? So, if I'm going to convert from atoms to moles or moles to atoms, I'm either going to multiply or divide, right? That makes sense. But I want you to set up what is called dimensional analysis. What I mean by that. When you start a problem, you always start with the given. Number one, how many calcium atoms are 0.25 moles of calcium? What is my given in this problem? What is my given? 0.25 moles of calcium. Why does that matter? Because calcium versus hydrogen, those are different masses, and when I'm looking for mass, it's going to make a difference. So, what do I start with when I'm solving the problem? What am I going to write first? The given, which is of calcium. Okay. Now, what do I know about 1 mole of anything? Because it's asking me for atoms. Well, I need to get rid of moles, right? If I need to cancel out moles, where should moles go?
On the bottom.
So, and what do I know about Avogadro's number? It's atoms per mole, yes? So 1 mole on the bottom, 6.022. It's, by the way, it's 22. Okay? Now, what do I do next? Everything next to each other gets multiplied, top and bottom gets divided. Okay? So all you do is multiply 0.25 times 6.022 times 10 to the 23, and that will give me a quarter of 6 is 1.5 times 10 to the 23 f.
And we keep it in scientific notation. Right?
Yes. Yes, you're not going to write out 23 zeros. Please don't write out 23 zeros because I can't grade that paper. Okay? Does that make sense? How we set that up? Okay? Now, can you set up the next one for me? What? What am I waiting for? You said wait, so I'm waiting. What am I waiting for though? I don't know. Yes? No? Yes?
You just do like multiply it by 0.250 to multiply that by the 6.
Yes. Yes.
And you put the rest the same.
Well, that's what happens. Math. Yeah. Math is good. Math is great. Calculators are even better. Okay. So, go ahead and set up the second one. The second one says what? What is it?
Calculate the moles.
Calculate the moles. And what does it give me?
The molecules.
That big number of molecules of oxygen gas. So what do I do now? What is my given now?
Number 3.75.
Right? Is that my given now? Yes. 10 to the 27. Sorry, that's molecules of oxygen. Okay? I write out molecules. Again, if you want to take out the O and the E's, you can do that, but I write out molecules. Now, if I'm going from molecules to moles, what do I need to do?
The molecules on the bottom.
The molecules have to be on the bottom. What should be on top? And it's always per 1
Mole.
Oh, okay. What number is this?
6.022 times 10 to the 20.
Now, here's where you have to be careful. When you are dividing on your calculator by an exponent, you have to put the whole thing in parentheses. So, you have to put in 3.75 times 10 to the 27 divided by this number in parentheses. Why? Because if you don't tell the calculator that you're dividing by 10 to the 23, it'll do order of operation, it'll just multiply by 10 to the 23. Okay? So, you're going to end up with 4 times 10 to the 3. Yeah? Come on.
Wait, what?
4 point something times 10 to
Oh.
the 3.
It didn't give it to me in scientific notation.
Well, tell me what number it gave you.
6,222. 6,227.1670.
That's how big the atoms come in. One more.
So 6.23 times 10 to the 3. Yes. That?
Yeah.
In parentheses. The entire thing. Yeah? Are you with me?
Wait, times 10 to the 23.
10 to the 3.
Why is it times 10 to the 3?
27 minus 23 is 4.
Yeah.
And then 3.75 divided by 6.022 is 0.6. You gotta move the decimal point and add. And subtract the next one. Scientific notation. We all know scientific notation. Yes, we do. I know, because I've talked to your math teachers.
I don't think I can.
I got like 6,000.
Yeah, that's what it is.
Oh, that's
Guys, you got... please, 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 you need to know scientific notation. And I know this is part of the curriculum of Algebra 1 and 2. You know this. I don't want your answer in non-scientific notation. I want your answers in scientific notation. If your calculator says 6,230, you should know that that is equal to 6.23 times 10 to the 3. If you don't know that, you need to see me at a different time. You need to make an appointment with me and I'll go over it with you. But in class, the assumption is you know scientific notation. Again, if you don't, come see me and we can have a chat. All right? Okay. Okay. Any questions on that? Now let's look at molar mass, and this is where we need a periodic table with us. So what I'll do is I'll print out some periodic tables. I have a few here and there, but I'll print out some, and the printout, when I print out the periodic table and give it to you tomorrow, I want that periodic table as part of your chemistry folder to come with you every day. Okay, because we're gonna need it from this point until June. Okay, so you'll have your own copy of that. All right, so molar mass, this is the average atomic mass from the periodic table. Now, instead of using that AMU unit, we're now using grams per mole. Okay, so now what you're going to do is you're going to find how many grams are in 1 mole of carbon. What do you do in order to determine that? Then you gotta find carbon on the periodic table, okay? So here is here. Take one and pass it back. You can share. I don't know if I have one for all of you, but I know I have enough where you guys can share. Just kind of put one in between you.
Wait, so wouldn't it just be 12 grams per mole?
Yeah.
So what's the difference between grams per mole and grams per centimeters cubed? Because before
Centimeter cube is volume. That's density. This is per mole.
Wait, so what?
Yeah. Okay. Did everyone get one periodic table at least you can share?
Yeah.
Yeah? We're good? Okay. Now, how many grams are in 1 mole of carbon? 12.01. Yes, everyone agrees with that?
Yes.
Beautiful. How many grams are in 1 mole of gold? Gold is right in the middle of the periodic table where the noble gases are. And 196.97. Okay. How many grams are in 1 mole of sodium? Sodium is Na. It's to the left. 22.99. Good. Okay. And what do they all have in common?
They all have 6.022 times 10 to the 23 atoms.
Yep. Avogadro's number, right? So 12 grams of carbon is 6.022 times 10 to the 23 atoms. 197 grams of gold is that many atoms. 22.99 grams of sodium is that many atoms. But because they're all 1 mole, that's the number of atoms. Okay? Now,